Okay, so we're recording. So the big ideas from this chapter, it's going to be a fairly quick one, but we're building on some important algebra skills that many of which you already have. Of course, I know in the past year for different people, your grade 10 course may have been in first term, in which case you got all this no problem, or it may have been a little bit disrupted. Either way, you're going to come out of this with stronger algebra skills. So the key ideas, we're going to determine whether algebraic expressions are equivalent. Like, are they equal to one another, even though they might look different? Can you add, subtract, and multiply polynomials? That's what we're focusing on today. Can you add, subtract, multiply, and divide rational expressions? So that's polynomials where like they're like a fraction and there's a numerator and denominator. How can we deal with those more effectively? And factoring. So using strategies to factor expressions. I'm interested to know right now a little bit about factoring because we're going to be doing a bunch of that tomorrow and I don't have a good sense of where you're at with that. Can you please post in the chat right now from a 0 to a 5 where you are with factoring? A 0 would mean I've never heard of factoring before. A 5 would mean I'm the ultimate master of factoring and I find it easy, no problem all the time. Or are you somewhere in between? Okay, it's okay to be any of those numbers. This will just tell me where we're starting from so that when I'm planning for tomorrow, I'll kind of know where we're at. So please post in the chat now. From 0 to 5, what's your comfort level with factoring? Okay, so we got a good range there. Lots of twos and threes, and then a few people that are like up around a 4.5. So what that probably means we need to do for factoring is cover the key ideas, and then I'll either need to record some extra videos or find some really good ones if I can that will support the people who maybe need a few more reps and need a little more comfort with factoring. I'm glad to hear that everyone who was able to post in the chat has seen it before and is at least a 2. If you weren't able to post in the chat and you're not there, like say you were a 0 or 1, please just let me know. Okay, you can always send me a message through Edsby. It'll be good to know where everybody's at. But we got quite a range, which means that's good. That'll help me with my planning to know for tomorrow that we've got quite a bit of a range. Okay, so that'll be for tomorrow. We'll do factoring stuff. Here's what I want to start with. Let's see if this will work. We're going to do a little fantasy dragon fight. So there's a bunch of terms on the left: variable, trinomial, binomial, factoring, coefficient, unlike terms, expanding, and like terms. And then on the right, I've got algebraic expression with 2 terms, value in front of a variable, algebraic expression with 3 terms, a letter that denotes an unknown, removing brackets, do not have the same variable in degree, same variable in degree, and 5x plus 15 equals 5 times x plus 3. So what we need to do is match these up. Let's say I chose like terms and stuck that as the shield. and then I chose 5x plus 15 equals 5 times x plus 3. Let's check our matches. Looks like, no, that's no good. My dragon has horribly murdered my knight. So I'm going to remove those and put them back, or maybe I just need to refresh. So here's what we're going to do. I'm going to ask you to start thinking, as these pop back up, I'm going to ask you to start thinking of some combinations that you know are correct. So see if you can pair some terms with definitions, essentially, or examples in this case. And then I'm going to ask you to let me know some that you think are correct in the chat. So don't post anything yet. I just want you to have a look at them. There's 8 of these. See how many of these you think you could match up with the correct term. Just think about it right now, and if you need to, jot yourself down a couple of notes. All right, we're back at it. I'm recording again. I just want to show you some stuff with algebra tiles. So the 11M textbook has a ton of algebra tile stuff in it. Some students love them. Some students just can't be bothered. So it doesn't, whichever one you are, that's great. If you really like algebra tiles, I want to encourage you to go for it. If you're not a fan, then you don't have to use it. I put 2 links here that I'll show you at various times, but these are links to algebra tiles interactive manipulatives. Algebra tiles are really effective with doing factoring. So I find they're maybe not as useful for other stuff, but for doing factoring, they're super useful. They can really help you understand things that might be hard to grasp without it. So here's what I'm going to do. I'm going to write an expression out algebraically, and then I'm going to use some algebra tiles to help us see what it looks like. Can you throw something in the chat right now, folks? I'm just interested how much experience, let's go again from a 0 to 5, how much experience you've had with algebra tiles. A 0 would mean I've never used them before. A 5 would mean I've used them a ton and I feel really comfortable with them. Where would you say you are on a 0 to 5 using algebra tiles? Either of them is fine. You don't have to use them, but some students really like them and find them really useful. So it's kind of a mix. I find usually about 1/3 of the students in the class are big fans of algebra tiles, and then 2/3 would choose not to use them. That seems to be the normal breakdown. Okay, so while you're filling those out, thanks folks, I'm going to write out some of my expressions here. I'm going to have 2x squared plus 3x minus 4. And I'm going to have negative x squared, let's do minus, negative x squared minus 2x minus 2. So let's do that, and what we're going to do is add these 2 expressions together. So I want to know what those 2 expressions work out to when we add them together. Okay? Wow, big range in algebra tiles. We've got a bunch of 0s and some 3s, 4s, and 5s. Really interesting. Okay, so an algebra tile, for those of you who haven't used them before, is just a visual way of representing variables. So when we're working with variables like x, we don't know how big x is, but here's how we can represent it. The long sides are going to be x. So that means with a big square like this, one side is x, the other side is x in terms of their length. So that means the area of that whole thing is x squared, right? Because that's how you do area, length times width. On the other hand, these smaller ones have a length on this side of x, and the smaller length we're just going to call 1. So x times 1, the area of this one is x. And these small tiles have sides that are 1 on each side. So the area 1 times 1 would be 1. We've got positives and negatives. And what I'm going to do is I'm going to pull these out to represent my expression. My first expression, and you'll see that these look different, right? You'll see that you can't easily add x squareds and x's together because they're not the same size. So that means they're unlike terms. So this is a nice way of kind of understanding what these might look like if you were to represent them visually. So first of all, our first expression, we've got 2x squared. So I'm going to pull out, oh, I didn't infinitely clone those. Give me a second here. I'm going to make this infinite. How about you? Are you infinite? I'll make all these infinite so I can pull off as many pieces as I want. There we go. Okay, so I'm going to pull off 2x squareds, and I'm going to put them right here. And then I've also got 3 x's, so there's 1, 2, 3. Oh, rats, I didn't group those together with their thingamajigger. Give me a moment to do that. Okay, I think we're good. So now I'm going to pull out 3 x's. There we go, I got 3 of them. And minus 4. I'm going to pull out 4 minus 1's. There we go. Okay, I got them all. Now the other one, let's add that one in. I got 1 negative x squared, just one of them. I've got 2 negative x's. And I've got 2 negative 1's. So now what I need to do is sum all of these up. So here's what I can do. One important thing I can do here is it's called the zero principle. I'm just going to start canceling these out. Emma, you remember that now? That's great. I'm going to start canceling some of these out. So I have an x squared, and I also find that I have a negative x squared. Those two are going to cancel out, right? A negative and a positive, they're going to cancel out, and they're gone. I also find that I have 2 negative x's, so I can group those together with 2 regular x's, 2 positive x's, and those will all cancel out. And the negative 1's can't cancel out because they're all negatives. So let's see what I'm left with. Looks to me like I'm left with a sum of 1x squared, 1x, and then how many negatives? 1, 2, 3, 4, 5, 6. 6 of them. So that's going to be my sum, x squared plus x minus 6. Most students won't end up using algebra tiles for adding or subtracting these because it can be a little bit slower. But that's the idea of how these are used, to represent algebraic expressions. And they can help a lot. With factoring, I'm definitely going to show you that because I know some students just love seeing them for factoring. So if you like algebra tiles, those links to those manipulatives, you might like them in this unit. And so we'll use some of them. Okay, here we go. Let's do a little bit of practice with our algebra skills. So remember, we can only add terms that are exactly alike. That means they have to have the same variable and the same exponent, right? They have to be the same degree, which means the same exponent. So an x cannot be added to an x squared. And if you think about our algebra tiles, it's because they're not the same size, right? They're not the same size. So we're going to collect our like terms. So I'd like you right now to just take, let's say, 58 seconds, so short amount of time. I'd like you to see how far you can get with these two. Start with number 1, see if you can get to number 2. Try these out, see how much of this you remember when we're dealing with like more complex stuff than we have been. Go for it right now. That bit. So I'm just going to start my recording so we can see that screen there with collecting like terms. Okay. Here's another one. I'm going to actually take you through these, but if you look at them and you say, yeah, I'm pretty comfortable with that, you can start plugging away at it. Go for it. Because practicing yourself is going to be most effective. For my first one, I look at this and I say, aha, I got some things in front of the brackets. So that means I'm going to need to multiply through the brackets. We've been doing this a bit throughout this year. Now this one I got to make sure I'm getting the whole -3. not just 3, but negative 3, and multiplying that through the brackets. So 2 times 2a is going to be 4a. 2 times b is going to be 2b. Negative 3 times 3a, so 3 times 3 is 9, but it's a negative times a positive, so it's going to end up being negative 9a. And a negative times a negative gives us a positive. 3 times 2 is 6b. Now we got to collect our like terms. I see I got some a's there. So 4a minus 9a, that's going to leave us with negative 5a. And then I got some b's there. 2b plus 6b is going to be 8b. And this is called our distributive property. I know that's a little hard to remember what's what. I won't be testing on what it's called. But just if you hear distributive property, that's a really common mathematical property, and that's what it means. If something is multiplying the brackets, you multiply it through everything in the brackets. Similarly, for this next one, this has an acronym that we say FOIL, FOIL. I've mentioned this before, first, outside, inside, last. So we're going to be, you're probably already pretty comfortable with these, but we're going to be doing these at a much higher, more difficult level. So we're going to practice them and try trickier ones. Basically, the way I think about this, you could think about it as FOIL. I multiply the first ones, I multiply the outside ones, I multiply the inside ones, and I multiply the last ones in each bracket. But you know what? FOIL doesn't work when we've got 3 things in our set of brackets or 4 things in a set of brackets. So how I like to think about this is, in a more sophisticated way, I like to think about it as everything in the first bracket needs to get multiplied by everything in the second bracket. So did we do that? Let's check. 2x, it's multiplied by both things in the second bracket. Check mark. Plus 1, is it multiplied by both things in the second bracket? Check mark, it is. So we multiplied everything in the first bracket by everything in the second bracket. We're good. 2 times 3 is 6, and x times x is x squared. 2x times negative 5 will give us negative 10x. 1 times 3x will give us 3x. And 1 times negative 5 will give us negative 5. Now, combining like terms. You might be tempted to combine all of your x's. You can't. 6x squared has a different exponent. Right? It's got a different exponent. It's an x squared, meaning you can't combine it with the other x's. Negative 10x plus 3, so it's going to be negative 7x minus 5. So I hope you're breathing a little sigh of relief and saying, gosh, this is way better than that intro to functions unit. This is stuff I'm familiar with. I'm feeling a little bit more comfortable with this. And with a bit of practice, we want to make sure that you're in really good shape, feeling super comfortable with this stuff. That would be awesome. That's what we're gunning for. Let's do a couple more examples, and then I'm going to want you to practice this, try this, and then get a jump start on that short assignment that I mentioned. Okay, here's another one. This is getting a little trickier. For number 5, I notice it looks kind of familiar to the ones I did on that first gray page right here. Kind of looks like number 2, but it's got fractions in it. Ugh, okay. Ugh. And number 6 looks a lot like the one I just did on the previous page. Number 4, we're multiplying through the brackets, but this bracket has a squared symbol there, which is going to complicate it. Ugh, okay. Well, let's give it a try. Let's go slowly but surely, and we'll figure this out. The first thing I want to do for my number 5 is I want to get rid of these brackets. So I'm going to notice that I've got a negative here, which means negative 1. So I basically need to multiply my negative 1 through everything in the brackets, all 3 terms. My first brackets I can just drop, so 2/3 m plus 1/2 n, and we're good. Now my next one, negative 1 times 1/2 m. It's going to be negative 1/2 m. And then I've got negative 1 times 1/4 n, so negative 1/4 n. And then -1 times -1 is +1. Good. So I've gotten rid of all my brackets using distributive property. Now I gotta rearrange this so my like terms are together. I won't be able to add them yet, because to add fractions we need a common denominator. We need the denominator on the bottom to be the same. Let's just write them together, because that'll be a little easier. So 2/3 m minus 1/2 m plus 1/2 n minus 1/4 n plus 1. Good. So now my m's are together, my n's are together. Oh, I missed one in there. My m's are together, my n's are together, and my regular numbers are together. Cool. Okay, now we're going to need to make the denominators the same. So we're going to, with fractions, we need to multiply the top and bottom. That won't actually change it if we multiply the top and bottom by the same thing. It'll just change the fraction to cut it into the same amount of pieces so we can add the pieces together. Looks to me like with a 3 and a 2 on the bottom, I need to change my denominator to 6 because both of those are factors of 6. They can multiply to 6. So I'm going to multiply the top and bottom by 2 on my first fraction and by 3 on my next fraction. I'm just going to write that out down below before we move on. So it's going to be 4/6, that's hard to say, m minus 3/6 m. Good. Okay, now let's do my n values. I've got a 2 and a 4, so I could leave the 4 as is, and I could just multiply the half by 2, top and bottom. And that'll give them the same denominator, so plus 2/4 n minus 1/4 n, and I still got my plus 1. Okay, so on my like terms, I made my denominators the same. So 4/6 m minus 3/6 m, so 4/6 minus 3/6 is going to leave us with 1/6 m. And I've got 2/4 n minus 1/4 n, so 2 minus 1, that's going to leave me with 1/4 n plus 1. And that's it. That's as much as we can do. We've removed the brackets, so we've expanded, which means removing the brackets, and we've collected our like terms to simplify. So if this question said expand and simplify, that's what we would do. Okay, our next one, number 6, is maybe going to be a little tricky. Let's get ourselves some space here. My strategy for tackling a question like this is going to be to go one step at a time. So the first thing I'm going to do, actually let me see if I can move this without moving the other one. Yeah, I can. Awesome. The first thing I'm going to do is I'm going to deal with that x minus 3 squared. If I can deal with that, I'm going to leave the 2x plus 1 alone, and I'll get back to it in a minute. So let's just deal with that x plus 3. So let's write out x minus 3, rather, as it actually looks. Squared just means times itself. So there we go, times itself. I just wrote it out as x minus 3 times x minus 3. Now let's do our multiplying through the brackets. FOIL. First, outside, inside, last. Okay, let's multiply all those out, keeping in mind that everything we're getting is going to be multiplying everything in the next set of brackets, 2x minus 1. So I'm going to keep those brackets on there. X times x is x squared. X times -3 is -3x. -3 times x is -3x. -3 times -3 is +9. Whew, okay. We multiplied through, and all of that is multiplied by 2x minus 1. Before I do anything else, let's collect our like terms. I got some x's there. I can't collect any other like terms because the other x's are in a whole nother bracket. So I can't just move them over. So we're going to have x squared minus 6x plus 9 and 2x minus 1. Now you might be asking yourself, hey Mr. Roy, can I go directly from x minus 3 squared to x squared minus 6 plus 9? Yeah, if you can do that in your head, go for it. Without some repetitions, that would be tough, but if you can do that, I don't mind you jumping that step at all. Okay, good. And we've arrived at this next spot. Now we're going to do this thing like FOIL, but the problem is FOIL doesn't work because there's 3 terms in our first bracket. So we need to just think about it as multiply everything in the first bracket by everything in the second bracket. This gets messy. If any of you end up taking data management, you're going to do some of this where it gets really ugly, and you're going to learn about this thing called the binomial theorem that's going to allow you to do this with things to like the power 11 or 50 or something, and it makes it much easier. There's like some systems to simplify it, but you could guess how this would get really messy if you had a bigger exponent than 2 in your original question. And so in data management, there's some cool techniques to deal with that if you take that, that grade 12 course, which any of you having done 11U or 11M could take. Okay, so let's multiply everything through the brackets. Got to multiply x squared by everything. Got to multiply 6x, negative 6x by everything, and got to multiply the 9 by everything. So I got to multiply everything in my first set of brackets by everything in my second set of brackets, making sure I'm not missing anything. Okay, so x squared times 2x is going to be 2x cubed. At x squared times another x, we add the exponents together, so it's going to be 2x cubed. And then I've got negative x squared. Okay, so I'm done multiplying the x squared through. Let's multiply this negative 6x through. Negative 6x times 2 is going to be negative 12x plus 6x. Okay, I'm done multiplying the negative 6x through. Let's multiply the 9 through. It's going to be 18x minus 9. Whew! Okay, it's a big mess. Let's look for like terms. First of all, I see I only have 1x cubed, so I'm just going to write that out front. I also see I only have 1x squared, so I'm just going to write that out front. Done. Nice. Now let's have a look at the other ones that are like terms. I've got 12, 6, and 18 are all terms with just regular x's in them. So I can combine all of those like terms. I'm wondering if I made a mistake here. Oh yes, I did. I made a mistake. Let's go back. I'll show you where it is. You might have picked it out already. And if you did, good on you. So x squared times 2x is going to be 2x cubed. X squared times negative 1 is negative x squared. Negative 6x times 2x, this should actually be negative 12x squared. So there's my mistake there. And other than that, I think we are good to go. So if you caught that, good on you. So we're actually going to have negative 13x squared because I'm going to add my like terms together right here and right here. And then my regular x's, I've got a 6x and an 18x. Those are going to add to 24x minus 9. Whew, okay. What a mess. Just imagine how crazy that gets when you've got even bigger and more challenging things to work with. And we're going to get there. We need practice, right? If you practice, you get good at it. Now I should say, when I have students doing this, if you make small mistakes, I'm not that concerned with small mistakes. If you can show me you understand how to do it, and you get a small mistake here and there, that's not a big deal. Like on an exam or a test, it would be like a half mark, a tiny amount. But but understanding the key ideas is where we want to go. Okay, a couple just extra examples I want to run through quick, and then I want to get us practicing. So the first one I want to start with are the following functions equivalent. I want to pause here. I want to give you 2 minutes to try and work on this. We're essentially saying, is the function f at m and the function g at m, are they equal to one another? If we expand and collect like terms and simplify, are they going to be equivalent? Are they going to be equal to one another? So I'd like you to take 2 minutes right now, try this out, see if you can show that they are either equivalent or not equivalent. If you do get an answer in those 2 minutes, post it in the chat. Let's go for it. Equivalent. let's dive in and see if we can figure it out nice and quick. So I'm going to go, let's go purple on my first one. I'm going to do this kind of quick because you've spent time with this. Let's multiply the m through the brackets. So we got 5m minus m squared. Multiplying the 2 through the brackets. So we've got negative 2m plus m, 2m plus 2m squared. Let's combine our like terms. Let's combine our m squared terms. We end up with 1m squared plus 3m. Okay, now let's do our next one and see how it's going to compare. Let's do this one in green. Let's multiply our 4m squared through the brackets. So we've got 4m cubed. Oh, right away I can tell these are not going to be equivalent. There's no m cubed in the next one. But let's keep going. Minus 4m squared minus 3m squared plus 5. Yeah, and that m cubed is not going to get canceled out, so it's going to be equivalent. It's possible it could have gotten canceled out, right? But it looks like it's not the case. Minus 7m squared plus 5. Okay, so we say not the same. Therefore not equivalent, because we've simplified them as much as we can. Not the same, therefore not equivalent. Okay, cool. Things might look very different, but actually be equivalent. So by expanding and simplifying, we can figure that out. Here's another example. This is a geometry type example. We get into algebra when we're doing area questions often. So again, we're looking at expansion of two binomials. We usually call that FOIL when we're expanding two binomials. Write an expression for the area of each shape, expand and simplify. So here's our parallelogram. It's got a base length of 2x minus 4. And you might say, like, how would a shape have a unknown? It kind of depends. If you're like manufacturing something and you're trying to figure out maximum or minimum sizes to reduce packaging, this is how you would do it. You'd use unknowns and then you'd figure out what the maximum or minimum was for x. You'd end up graphing a quadratic and figuring out where your vertex is. So this is actually quite useful math in terms of figuring out like the most efficient way to do things. So, and the height is 2x plus 3. Now the formula for this is the area is base times height for a parallelogram. So that's great. So let's do that. We're going to get ourselves a little more space here, and we'll go the area of our parallelogram is the base, which is 2x minus 4 times the height, 2x plus 3. Now the 11M class, you're going to find more of these in your book. These are more commonly problems in your book. For the 11U class, you will see some of them, but the majority of them are in the 11M book. Let's multiply through here. 2x times 2x is 4x squared. 2x times 3 is going to be 6x. Negative 4 times 2x is negative 8x. And negative 4 times positive 3 is negative 12. Let's combine our like terms. We've only got 1x squared, so there it is. We've got positive 6x's and negative 8x's, so we go up 6 and then down 8. That's going to leave us at negative 2x minus 12. And that's the expanded and simplified expression for the area of this parallelogram. Okay, so we might be doing a problem where you're dealing with things like area, and there's like a geometric thing. I want to end with one last thing, and this is going to be like a really ugly one. Oh, this one isn't the one. Oh yeah, let's do both of these. I want to kind of move fast through these though. These are two tricky ones, and I want to just kind of show you, I'm going to move it at a pretty quick speed, and I'm going to show you kind of how mucky these can get. Okay, so here's our first one. We'll do it in blue. 4x minus y plus 4 squared. So if we're going to expand, we first want to actually write out what it is that we're multiplying. Squared just means times itself. So there, we've done that. Now we've got to multiply everything in the first bracket by everything in the second bracket. So let's start with our 4x. 4x times 4x is 16x squared. 4x times y is going to be negative 4xy. 4x times 4 is going to be 16x. Whew, that's our first term in the first bracket multiplying everything in the second bracket. Let's move on to our second term, the negative y, and multiply that through. Negative 4xy. You'll notice I'm writing my x first and my y second when they're combined together in one term. That just makes it uniform. It could be yx, it doesn't matter. But I want to write them the same way each time so they're easier to recognize. Plus y squared minus 4y. Oh gosh, this is long. Okay, let's take that 4 and multiply it through. Plus 16x minus 4y plus 16. Whew! Okay, what a mess. First, let's look for our x squared terms. Looks like there's only one of them. 16x squared. Then let's look for our terms that have just an x in them. I see one there, and I see one there. So that's going to be 16 plus 16, that's going to be 32x. Now let's look for our terms that have an x and a y. There's one right there, there's one right there, and that's it. So negative 8xy. Now let's look for our terms with a y squared. Right there. Actually, let's do that next. That's good. So y squared right there. So it's just the 1, so plus y squared. And now our terms with just a y. We've got one right there and one right there. So we're going to go negative 8y. And then we got our plus 16 because it's the only regular number. Whew! So that's what it works out to. What a mess. 16x squared plus 32x minus 8xy plus y squared minus 8y plus 16. Our last one, this one is a huge mess. I'm not sure I want to go through this with you today because it'll take a while and I think it's time for you to start practicing stuff yourself. If you've been listening to me go for a long time. So let's stop there and I'll show you this one tomorrow. Here's your stuff for today. So each class has a different bit of textbook work to practice and reinforce your learning. Of course, a reminder, the textbook solutions are available. I posted them in the content section. So you may want to use those to help you out. Okay, this is meant to be practice to reinforce your skills and your abilities, and you need repetition in order to feel comfortable with this. There's also an assignment. It's pretty short, okay? And it's actually the same assignment for both 11M and 11U because it's in the curriculum for both your classes. It's expanding and simplifying polynomials that's due tomorrow at 10 p.m. So that gives you tonight and tomorrow evening if you need more time to work on it. If that deadline is an issue for you personally, send me a message and we can talk. But that's when I'm going to set it initially unless I hear differently from you. And it's quite short, so I don't think that'll be too much of a problem. Now I've posted that on Edsby. If we scroll down, that's all right here. Here's our homework practice and our assignment. And the assignment is located here, attached to the bottom of Edsby. So if I click that, it's going to take me to the assignment. And there it is. It's a little bit off the recording screen, so I'm just going to expand this here so you can see it. All right. So we got essentially one page front and back. There's a bunch of questions to expand and then simplify all the things we've covered in our lesson today. Oh, Haley, today's the 26th. Thank you for catching that. I have it correct on the top of the assignment here, Tuesday, October 27th. Looks like I do not have it correct on Edsby, so I'll make that change as soon as I stop talking. So it's going to be tomorrow, October 27th. Thank you, Haley, for catching that. Good eye. Okay, so let's get to work. We got about 20 minutes right now. That means we can put a serious dent in this stuff because it's pretty short, it's pretty fast, and let's get those repetitions, okay? So let's jump in right now. If you would rather jump in with the assignment first, you're welcome to do that. I'm okay with that. If you'd rather do the assigned practice first, go for it and do that first, okay? I'm going to stop the recording now, and you can jump in and get to work. And I'd love to hear some of your questions as they come up. Let's go for it.